arithmetic series, or actually more technically correct, it is about finding the partial sum of the terms of an arithmetic series. So let's start out with a specific example that we'll make up right now. Let's say that we have this list of numbers: 8, 11, 14, and 17. Just a brief list. And let's say that what we're actually interested in doing is adding 8 plus 11 plus 14 plus 17. It's pretty easy to do. You can do it longhand. 8 plus 11 plus 14 plus 17. 8 plus 1 is 9, plus 4 is 13, plus 7 is 20, 0. Carry the 2. 2 plus 1 is 3, plus 1 is 4, plus 1 is 5. So this short list of numbers adds up to 50. Now let's notice that the numbers that we're adding up actually happen to be the members of an arithmetic sequence, because each of the numbers differs from the previous number by 3. So we're adding 3 each time to create the list. Now, there's an entirely different way to go about getting this result right here, 50. And it's done by means of a formula. And before we use the formula, though, let's figure out what we should use as notation. So 8 is T1. The fact that we increase by 3 each time, that tells us that D, the common difference, is 3, and we are going to add together 4 of these terms, equals n over 2 times the quantity 2 times T1 plus n minus 1 times D. And so now let's fill some numbers in. We're looking for actually S sub 4, the partial sum of the first 4 terms of this sequence. So that's going to equal 4 over 2, 2 times 8 plus parentheses 4 minus 1 times 3. And then magic happens, and the result is 50. Now it seems like we've just gone about this in a very complicated way, but that's because we would only have been adding together 4 terms. Sometimes you have to add an incredible number of terms, and it seems almost
inconceivable!
You're gonna need a bigger boat.
Well, what the hell is supposed to do, you moron?
War's over, man. Wormer dropped the big one.
What? Over? Did you say over? Nothing is over until we decide it is. Was it over when the Germans bombed Pearl Harbor?
The actual problem for today is asking you to add together the members of this arithmetic sequence, but all the way through the 240th term. So let's figure out what we need to know here. What we're doing is we're taking 44 plus 52 plus 60 plus 68 plus ... all the way through 240 terms. So that means n is going to be 240. The very first term, t1, is 44. And we need to figure out the common difference. So we go back up to the list of numbers. 44 plus 8 is 52. 52 plus 8 is 60. And so we realize that the common difference for this arithmetic sequence is 8. So on to utilizing the formula. S sub n equals n over 2 times the quantity 2 times t1 plus n minus 1 times d. In this case, we're adding together 240 terms, so n is 240. 2 times the first term is 44, plus 240 minus 1 times 8. And then it's just a lot of arithmetic to finish up the problem. 120 times the quantity 88 plus 239 times 8. 120 times the quantity 88 plus 1912. 128 times the quantity 2000 equals 240,000. That is the 240th partial sum of this arithmetic series.